I'm Tom Cobett. I work for an organization called the Foundry Education Foundation. Joining me is Trent True, actually Professor Trent True from Kent State University. Metal casting is nothing more than the act of melting metal, pouring it into a mold, and then picking up the shape of that mold. It's the fastest way to go from an idea to a finished product with metal. Everything in the world that is made out of metal, everything at one point was melted to a liquid. And usually that first point is when it's extracted from ore. Most metals exist as oxides in the earth. We can take those oxides, combine them with things like carbon, extract the oxygen away, and now we have liquid metal. The liquid metal is poured into an ingot or into some sort of a billet, and then it's further processed or further alloyed. Most things today that are complex as metal shapes, things like car parts, boat parts, aircraft parts that are made out of metal, are made as metal castings. We simply make a mold out of something that's reusable and refractory, and then we melt metal, pour it into the mold. That simple act of metal casting is done in a business we call a foundry. So here's how this works. We're going to make molds out of sand, and we're going to melt metal. The metal we're going to melt today is tin. We use tin because it's very, very shiny. It's non-corroding. It has a luster very much like silver. And we specifically use it as a very, very low melting point. At 450, this will melt to a liquid, and it flows very, very nicely. We're going to melt this by putting it into a microwave. What do you know about putting metal into a microwave? Most people say it's a bad idea, but in reality, what happens, microwaves bounce off of metal. They hit it, bounce off. They're not absorbed. So if we could take the metal and put it into a container that was made out of microwave-absorbing materials, and then we put the metal inside, put it in a microwave, turn on the power, the container is going to absorb all the microwaves and get hot, 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 hot. And then whatever's inside of it is going to melt like a stick of butter in a crock pot. So this crucible is actually made out of a blend of titanium dioxide, zirconium oxide, and iron oxide. This one was one we're going to make. This happens to be of a gecko. That's half of it that side, half of it that side. All right. This is called a match plate. It's also called a pattern. The pattern is put into two boxes, two halves of a box. The bottom half always has these pins on it. We always put the pattern down so that the highly detailed side is down. Then we put the top of the box on. And then we're going to start by flipping it over, and we're going to pack sand into the bottom of it.
I got this.
Okay,
I'll talk. I'll work.
You will. The sand we're using, how many of you, you're just young enough, you can probably remember moon sand on Saturday morning cartoons. This is industrial moon sand. It's the best way I can describe it. It's non-toxic, it has no water in it, it's bonded together by clay and a non-toxic oil called amorphous polybutene. Once we flip it over, we're going to pack it again. And if you notice, every one of these flasks has some marks on it. Where those marks line up, we're going to put a hole in here. That hole is where the metal is poured in. Almost all the time we have to put weight on top of our molds. You just heard my microwave go off. We now have liquid metal, and we're going to pour it right down the hole. When this metal inside of here is solid, that's the thickest part of the casting. When that's solid, everything inside will be solid. It'll be hot, but it will be solid. What we're going to do is dump the sand into this bucket. If we did this right, we should have a gecko. We have it, right? It's got all 4 feet. We're going to take the sand that's been used once, pop it out, take this, pop it out, grab a pair of pliers, grab your recently cast piece of metal, and we're going to put them in a bucket of water, and it'll sizzle just a little bit. But because heat transfer is so fast in this metal, this is very similar to copper in heat transfer, it's already cooled down to room temperature. We're going to take and clean off any of the extra sand, extra metal we cut off. Seven minutes ago, this was chunks of hard metal and no sand mold. In 7 minutes' time, we melted the metal, made a mold, poured it in, got it to solidify, and made it into a useful shape.